Hello, Internet, and thank you very much for tuning into the Cloud Native Islamabad YouTube channel. And what we are covering today, Flux. GitOps love Flux, and Flux love GitOps. And I tell you, I will let you know why. And that's the gist of what we actually Flux community achieved. Our year Flux 2.0 GA is recently rolled out. And today I'm speaking with one of the guests who is associated with this project, I think from day 01. So let me give you some insight what we're covering today, and then I jump into the guest you like most. So let me straight talk about. So Flux reached major landmark with Flux 2.0 and the general availability of its GitOps component. So Flux has continued to grow during its incredible journey. The API that have reached GA include Git repository. This API facilitates pulling configuration from Git repositories, customization. It enables the application and synchronization of Kubernetes manifests defined in Git. Receiver API. This API triggers the reconciliation of GitOps custom resources using webhook. And what we actually covering today is you get a hands-on experience setting up GitOps pipeline and managing Kubernetes resources declaratively, and you will be exploring real-world use cases and best practices for implementing GitOps with Flux. So without any further delay, thank you very much, Stefan, on the show, very first time your appearance on this YouTube channel. Over to you now, your intro, then we start the workshop.
Great to be here.
Thanks, Stefan.
So can you give before we start talking about Flux and everything, yeah, it's about GitOps in the end, right? And GitOps right now has reached, let's say, it's mainstream. And like everything that becomes mainstream, like DevOps before and everything, it means different things to different people, right? So let me ask you what GitOps means to you.
For me, GitOps means Flux for me.
Nice. Yeah. So, yeah, GitOps means different things. To us, the Flux project, it's more like a guideline on how you can implement continuous delivery for applications, clusters, infrastructure, everything that you need to run somewhere in a cloud or maybe on-prem or maybe on a server in your own household, right? And we try to make this as smooth as possible without much interactions between operators and the actual production clusters or servers. And how we try to do it is using Git as a proxy in a way. Well, Flux is a proxy. Git is more of a state storage. So in a classical pipeline, if you want to deploy something on Kubernetes, you need to build a container of your app. Then you need to write a Kubernetes deployment manifest. Can be quite a large YAML file. And then you do kubectl apply of that manifest, right? It gets applied on Kubernetes, and from there, Kubernetes takes it on and deploys your application. Now, if things fail, you have to, tail the logs, ask Kubernetes how the app is doing, and all of that. Next step from here, instead of, humans doing kubectl apply, you have some kind of automation. And what automation is there from start? Probably some CI pipeline. I don't know, Jenkins, some GitHub action, where you do the Docker build and Docker push commands. You also add there kubectl apply command, and you connect your CI infrastructure to your production system. You give it access to your Kubernetes API server, and that's how you can automate the deployment. What Flux is trying to do is we try to offer a way of decoupling the deployment part from the continuous integration from the build part. So instead of your CI tooling building, then going, connecting to the production cluster and deploying there the things, instead of doing that, you build your application, then the cluster should be able to detect, oh, there is a new version of the application, which is pushed to the container registry and should deploy your app on its own, unattended, right? So how all of this works is you put your Kubernetes manifest in a Git repo, then you make your cluster look at that repo and synchronize its state from there. So it's not only about application, it's also about cluster add-ons, CNIs, ingress controllers, everything that you need to run your system. And this approach may sound more complicated than just running kubectl apply when you change your application. It is in a way more complicated because you have to set things up in advance, but afterwards, after you do the initial bootstrap of your clusters, things can the continuous deployment and continuous delivery can run on its own, unattended. And that's what we are trying to do with Flux. Also, scaling out from having a single cluster where you deploy there to maybe I have a staging cluster and a production cluster, and even the next step after that is maybe I want my production clusters to be my production system to be close to the user. So have more than one production cluster, maybe one per region, and so on. So the more you add environments where you do the deployment in a typical CI system, every time you add a new cluster, a new region, and so on, you have to go into the CI system and configure kubeconfigs, opening up access there, and so on. With Flux is more about you have one Git repo, and in there you define how many environments you have, and automatically those clusters belonging to those environments will look at that repository. So what I'm trying to show today is how do you bootstrap Flux, what that means, right? And how we can structure a Git repository to deploy things from external sources. For example, how you deploy a Helm chart from a Helm repository, how you deploy an app coming from some other Git repo which you don't actually own. So I'm going to share my screen. That's okay? Can you see my screen, Simon?
Yes, Stefan, I can share your screen, and an audience, if anybody doesn't able to see your screen or anything, please ping me. I'm off the line. It's now up to Stefan to give us a walkthrough of the Flux. So over to you now, Stefan.
Okay, so I have prepared the Git repo on GitHub, and I'm going to use this repository to kick off Flux and a cluster. So there are a couple of prerequisites that you need to have in order to follow this workshop. One is you need a Kubernetes cluster, and the easiest way to get a Kubernetes cluster on your local machine is using the Kubernetes kind project. Is CLI that interacts with Docker. So for example, I'm running on a MacBook, everything. I have Docker for desktop, and I can run this command, which is kind create cluster, and I'm going to name my cluster staging. I'm going to run this command, and the cluster will kick off. So that's step one. Step two, you need to install the Flux CLI. The Flux CLI is a binary that works on any desktop systems, be it Windows, macOS, Linux, Linux ARM64, and so on. How you can install it is using brew. for Mac, and we have various installation methods here on our website. So you can use Homebrew, you can use a bash script, you can use YAI, Nix, Chocolately for Windows, and so on. And it also comes with auto-completion, so you don't have to remember and type long commands with it. Okay, I have Flux installed already on my machine. Final prerequisite is you need to have a GitHub personal account token. And I'm going to explain a little bit why is this needed. So the Flux CLI has a command called Bootstrap, which sets up Flux on a cluster, and then that cluster is synchronized with a repository. In order for the Flux CLI to set up all the things in your Git repo, it uses a GitHub personal account token that doesn't leave your machine to do the initial setup. And we are going to see what that means. The CLI wants an environment variable called GitHub token. You put there your personal access token. That token must have permissions to create repositories on your personal account, or if you are using an organization, the same. And we are going to set up the token and the GitHub username. Why we also export the GitHub username? If you want to follow this, you'll have to fork this repo, and you'll have a different URL here. Instead of Stefan Prodan, you'll have your own username. So we use the GitHub username variable in all the commands, so it works for everybody. After you fork the repo, you can clone the repo locally with the git clone command. I'm going to use, instead of cloning the git repo locally and do modifications on my own machine, I'm going to use GitHub code spaces. Let me see if this is fully initialized. Okay, it has started. So I'm going to use code spaces to, you'll not watch me do typos in YAMLs. I have prepared the YAMLs. They are in the repo already, but they have a .x extension, so Flux is not aware of them. So how the workshop will go, after we'll do a step, we'll rename some files, then those become Kubernetes manifests that Flux can see and apply. Let's see if the cluster is ready. Okay, so I have a cluster. Let's look at the namespaces on those clusters. It's a empty cluster kind, nothing special about it. Okay, so I have a cluster. I have a Git repo, and I want for this cluster here to synchronize its state from the Git repo. So how can I do that? We offer a single command called Flux Bootstrap that has many variations. And I'm going to use the Flux Bootstrap GitHub variation. We also have it we also support GitLab, Bitbucket. We also have a generic Bootstrap Git command that works with any kind of Git server out there. And we have also documentation in place on how you can do Bootstrap for Azure DevOps repositories, AWS Code Commit, Google Cloud, and so on. So the idea is no matter where your Git server is, if you have access to it, you'll be able to run this command against it. Okay, let's get started. I'm going to copy the Flux Bootstrap command in my terminal. And because I have created the kind cluster before, my kubeconfig context is set to that cluster. The Flux CLI is akin to kubectl. It also has the same arguments like -- context or -- kubeconfig and all of that. All that you are used to do with kubectl to connect to Kubernetes clusters, all these things work the same with the Flux CLI. Okay, so the Bootstrap GitHub command has many arguments, but these are the most important. What you see here is the owner of the repository, and I'm setting this to an environment variable, which resolves to my GitHub username. I give it the repository name, the branch. I tell it that, hey, this repository is on a personal account, not an organization one. And the last thing, which is the most important thing, is where I want to bootstrap the cluster inside the repo. And I'm giving it a path called clusters staging. The idea behind Bootstrap is that from a single Git repository, you can control more than one cluster. And the convention is, and a good practice is, to use this kind of path. Clusters and your name of the cluster. Now, the naming can be based on environments, I don't know, staging, production, whatever, or the actual cluster name and so on. That's up to you how you organize these things. Okay, let's run it. Oh, maybe the GitHub username is not here. 1 second. Oh, yes. I forgot to export this variable. Going to do it now. Okay, let's run the command again. This time it should work. The output is telling us what the command is doing, and it does a bunch of things. And instead of trying to decipher the logs here, I'm going to show you a diagram I made, which tries to explain what's happening now. So you run Flux Bootstrap, and the CLI connects to two different APIs. One is the Kubernetes cluster using your kubeconfig, and the other one is the GitHub API using the GitHub personal access token. On the cluster, it installs the Flux controllers, and we'll see them in a minute. And in the Git repo, it will push those controllers manifests. So all the things that make up Flux, all the controllers, namespace, RBAC, everything is pushed to the repository under the path that you gave. In our case, is clusters staging. And after it does all of that, it also it generates an SSH private key. That private key is stored only in the cluster, and the public key of the SSH private key, the public part, is set in with the GitHub API as a deploy key on your repository. Let's see if this is okay. So this has finished. Now, if I'm looking at my Git repo here, let me refresh it. I'll see now that there is a new commit made by Flux, add Flux sync manifests. Let's look what's happening here. So there are basically two commits. The first one is add Flux version 2.0.1 components manifest. And if we look here, we see that the Flux CLI using my GitHub personal account token has pushed to the repo a huge YAML file with everything that makes up Flux. CRDs, namespaces, and so on. That's one commit, and the other commit is Flux sync manifest, and I'm going to explain a little bit what this means. So these are the Git action that the Bootstrap has performed in the repo. Now, if I'm going to settings of my repository under GitHub and I'm looking at deploy keys, I see that a new deploy key has been created for my staging cluster. So we use the path.
Sorry,
Yeah.
Stefan, to interrupt you. Just the audience, can you just increase the font size of the GitHub? Yes, that looks perfectly fine.
So this deploy key was created by the CLI using the public key of the SSH private key that it has generated, and it sets up here with a unique name using the path that you gave. So if, let's say, I'm running on the same repo, Flux Bootstrap for the path clusters production will get a new deploy key here, right? And one important thing to note, this deploy key has been generated, has been uploaded to GitHub using your personal access token. If your token expires, also this deploy key expires, and Flux will not be able to connect to the repo. If I want to disconnect Flux from a particular repo, I can just delete the deploy key, right? Now, let's see what happened on the cluster itself. If I'm doing get namespaces, I see that we now have a new namespace called Flux System. And if I'm going to the repo here, I see that there is a cluster staging directory which has a Flux System directory inside. So what's in here is reflected on the cluster inside this namespace. If I'm looking at things that are running inside this namespace, I see that we have 4 pods. There are 4 pods, 4 deployments, and so on. These are the Flux controllers running on your cluster. So Flux is made out of many things. Some are optional, some are not. These are the default controllers when you run Flux Bootstrap. Of course, you can remove some of the things. If you don't use Helm at all, you can Bootstrap without the Helm controller. If you don't care about Flux notification, if you don't want to know when something fails, you can opt out of notification controller. What the minimum requirement for running Bootstrap is source controller, which is responsible for connecting to the Git repo and pulling changes from there, and customize controller, which is the controller that applies things from the repo on your cluster. And it can apply plain YAMLs like we have in this repo, or you can use customized overlays, and it also knows about those. Okay, now another thing, if I'm looking at Flux system and I'm looking at the secrets inside this namespace, there is a Flux system secret. This secret contains the SSH private key, right, that I was talking about. Now, let's say I want to, rotate the key, or maybe my token has expired, so Flux cannot connect to it, and so on. What I can do is I can delete this secret, rerun Flux Bootstrap, and Flux Bootstrap, the CLI command, will detect, oh, an SSH key is not configured. It will create the secret, it will generate a new key, it will create the secret, then it will go here in GitHub under settings at the deploy key, and it will update this deploy key for the staging cluster. So it's quite easy to rotate keys, or if you made some mistake, you can reboot everything with this command. Now, once I run Flux Bootstrap, all things from this moment on can be done. All the things that I want to do on the cluster can be done inside the Git repository itself. I don't need to connect to the cluster anymore. So let's start by deploying things. And the first thing that I'm going to deploy is with GitOps, which is an application that is Web UI for Flux. It shows all the things that Flux does. You can use it to monitor Flux, to understand what Flux is doing, and so on. So with GitOps, like many Kubernetes add-ons, is packaged as a Helm chart. So in the Flux world, if you want to deploy Helm, you are not going to use the Helm CLI. Flux offers a declarative API on top of Helm. So we use the same Go SDK, the same source code as the CLI uses. and we have this code. The SDK is used in Flux Helm Controller, and we offer 2 APIs, which are in Kubernetes world called custom resources. We offer 2 custom resources that allows you to install Helm charts, upgrade Helm releases, delete them, modify them, configuring them, and everything. Everything that you can do with the CLI, you can also do declarative with these APIs. So first, I'm declaring a Helm repository object, which points to where the charts are. And in Flux supports charts stored in Git repos, in Helm repos, HTTPS ones, but also charts stored in container registries. And this is what we are using today. And I recommend you, if you are doing Helm in your own organization, please consider, instead of using the classical Helm HTTP repository, please consider using your container registry to store the charts. The Helm push command is capable of pushing charts to container registries, and I strongly advise you to look into it. Okay, so first thing, I'm declaring the Helm repository, and I'm telling Flux which repository in this container registry contains the charts with GitOps. And in our case, with GitOps is hosted on GitHub Container Registry in the charts repo. So I'm defining here the source, and Flux here will find all the charts versions with GitOps. Now, to actually deploy this app from its chart, I'm creating a new object called Helm Release, which has the source set to the Helm repository. I'm telling the chart name. I don't specify a version. It's star, it's get me latest, according to Semver. And here under values, I can customize my chart. And what I'm doing here, basically, I'm setting a more secure deployment where I'm dropping all capabilities for this app. And I also create a username and a password so we can access the UI with it. How can I deploy this on the cluster? So if you see, this definition is in a different directory structure under infrastructure, under controllers, and we have this YAML here, right? If I want to deploy this on my staging cluster, I need to add it here under staging. So first I'm going to synchronize whatever Flux has pushed, so I'm not running into conflicts. Come on. Okay. So now I should see this. Yes. Okay. If you are on your local machine, you should do a git pull after the Flux Bootstrap, so you get the changes locally. And here I have file.x, so Flux doesn't see it, which tells Flux how to install the infrastructure bits on my cluster. So I'm going to rename this file. Going to remove the .x, so it's just YAML, so Flux can see it. And I'm going to say deploy infra. I'm going to commit and push these changes to the main branch. Now, on the cluster, I can do Flux get customizations minus watch. What the watch command is doing is basically waiting and reporting all the Flux customizations present on the cluster. And we have a single one, is the Flux system one that we've created during Bootstrap. So during Bootstrap, the configuration is we tell source controller, configure source controller to watch for changes in the repo every minute. So if we wait long enough, we should see that, okay, it's starting. Flux has seen, oh, there are changes. I have now these infra customizations I have to reconcile. And what it does now, it has pulled the changes. It has detected, oh, there are new things to deploy. It has started deploying them in a particular order, and we are going to explain what that means. And after deploying each workload, it waits for that workload to become ready. So for example, the Flux UI is a Kubernetes deployment. It has applied that deployment, and now it waits for the deployment to become ready for the pod to spin up. There is also horizontal pod autoscaler, other things there, and it waits for all of them to become ready. Then it moves to the next thing, which is called infra configuration. And let's see why we did it. I want to explain a little bit why we have infra controllers and infra configuration. So here inside infrastructure, I have created two directories. One is called controllers, and this is the directory where you would place cluster add-ons, like, for example, here, because I have a kind cluster, I need to install metric server for my horizontal pod autoscaler to function, right? So how I'm installing metric server, it's of course from a Helm repository, the official one. This is an HTTP repo from Kubernetes SIG, and I create a Helm release for it. And I can add here, I don't know, kube prom stack, cert manager, an ingress controller, all things that extend Kubernetes can go here under controllers. What's important to note is that inside the infrastructure YAML under my cluster here, I have two customizations for each directory. One is the controllers, and one is configs, configuration. So what I'm doing here is I'm defining two separate things. And why is that? Why I have two directories and not just one? The thing with controllers is that third-party controllers, right, from outside the Kubernetes built-in one, they contain custom resource definitions and their controller deployments and other things. Now, if I want to deploy the controller, its custom resource definition, then I want to configure something with a custom resource. Let's say I have cert manager. I install cert manager that contains the certificate custom resource. Now I want to create a certificate. Flux will not allow me to mix these things in a single apply unit, in a single customization. And why is that? Is because Flux enforces that everything that it applies, the cluster API, the Kubernetes API must know about that resource, and it must be valid. So it's a chicken and egg problem, right? You can't validate a custom resource if you don't have its definition already registered in the cluster. So how we are structuring our repository is in the controllers, we put there the custom resource definitions and the controllers. And in the configs directory, there we can have, I don't know, certificates, network policies, whatever, right? Custom resources. And we use this construct, which is called depends on in Flux, where we say this portion, this reconciler, the infra configuration, depends on controllers. What that means is what Flux does, it will install the controllers, wait for the controllers to be registered, wait for their custom resource definitions to be installed, on the cluster, and only after that we'll move to the second bit where it applies custom resources for that definition. And this ensures that even if you have all this repo with many controllers, custom resources, whatever, and you want to spin up a new cluster and use the same deployments there, the same cluster add-ons and everything, even if you have all these things defined in your repo, Flux will know after Bootstrap what to do. And first we'll install the controllers, definitions, then custom resources, and finally applications. Okay.
Just one question from the chat in the chat. So Manuel is asking about workflows with Flux. Should I suspend or resume Helm releases if I want to test changes from a branch not merged? The test window can take days for review. Any better workflow recommendations?
So if you want to test a change of a Helm release, you should have at least two clusters, a staging and a production one, right? So what you'll do is, let's say you open a pull request for your staging cluster, where you do the staging, the changes there. You run static validation on that pull request, then you merge it. It automatically gets deployed on the staging cluster. And from there, you can build automation with Flux, and Flux will promote that change from staging to production only if, let's say, Helm tests are passing, or maybe you have a manual process where you do the testing on your own and you do the promotion on production. But no, you don't need to suspend anything to test things. You should have different clusters, especially for cluster add-ons. Cluster add-ons are a thing that install global stuff on the cluster, like custom resource definitions, what I was talking about. So you can't create a namespace and test there, let's say, a new version of Cert Manager or whatever. Why? Because once you deploy the new version, even if the deployment of the controller goes into a namespace, it will override the custom resource definition for the whole cluster. So for cluster add-ons, using namespaces to test things does not work. You need separate clusters. For applications which are not controllers and so on, of course, you can have different namespaces, and I don't know, using Flagger, which is another project under Flux, you can actually do the testing in your production environment and shift traffic between versions and so on. Okay, let's move forward. So what I have now on the cluster are like three things. The Flux system customization, which is responsible for managing Flux itself. So Flux is now watching the repository, this directory, Flux system, where its own manifests are for changes. And if we want to reconfigure it or add other controllers to Flux and so on, we will do it through the Git repo, and Flux will upgrade itself. And the infra controllers are watching this directory. If I'm adding here a new cluster add-on, I don't know, maybe I want to add an ingress controller or whatever, they will get synchronized, and the configs if I'm doing all sorts of configurations for those controllers. Now, if I can look at all the Helm releases that I have on the cluster. Let's do this. We can see that I have two Helm releases. One is with GitOps, the Flux Web UI, and the other one is the metric server. Now let's access with GitOps in the UI and see how that looks. So I'm going here, and I'm going to do a port forward. Of course, if you have an ingress controller, you should set up an ingress controller and not do port forwarding to access things on the cluster. But for the simplicity of it, I will use port forwarding. And here now I should have access to the user interface of Flux. Username is admin, password is Flux. You can change it in the Helm release and so on. So here is how with GitOps looks. It has a dark mode and a white mode. I'm going to stick with the dark mode. And what this UI is showing is basically the same thing that you would see from the command line. It has an application view which shows Helm releases and Flux customizations. It has a source view where we have our Git repos, our Helm repositories, Helm charts, and all the sources that make up our cluster, and other things like image automation, the Flux runtime where we see all the Flux controllers, and the Flux CRDs that are registered on the cluster. Of course, it also shows us the Flux version and so on. So, okay, how can I see the dependency tree and how things are reconciled on the cluster? Let's look at infra configuration, for example, and I have here a dependency view where it shows how things are going. So infra configuration depends on controllers. This is what we had in the YAML. If we want to see from where they come, we have this graph view where we see that these things come from the Git repo through the configuration, and this is how the network policies are being deployed with GitOps. Right, so you can use the UI to basically understand how things are being positioned and executed in the pipeline without having to, read all the YAMLs and so on. Okay, let's go back a little bit to the repo, and I want to go back a little bit at the start where we run Flux Bootstrap, and Bootstrap has created this GOTK sync.yaml. So here is kind of an inception. So we have a Git repository object that refers to this Git repository and this branch, right? And we see here the secret ref, which points to the name Flux system, the one that Bootstrap has created. And this is how Flux knows how to synchronize itself. Where is the source, right? And we have here the SSH address and so on. And here is the Flux system customization that applies everything that's in clusters staging. And inside the clusters, we don't actually have here Kubernetes deployments and so on. We have other Flux customizations which are applying other Flux objects like Helm releases, Helm repos, and so on, right? So with this, we basically define our pipeline in such a way that the Flux system customization applies all the other top-level customizations that are responsible for installing cluster add-ons, the configuration of those, and applications. If we go, for example, at applications and we want to see, hey, what's a Helm release made of with GitOps? What has deployed on the cluster? We have this view where the UI shows us all the Kubernetes objects which were in the Helm chart and were deployed by Flux. And we see their status. We see, for example, the containers that got deployed, the status of each deployment, and so on. We also see here in the graph visual representation of the clusters, deployment, replica sets, pods, and so on. And we have this, which is of great importance if you want to debug Flux, is the event view. So Flux, for everything it does in your cluster, it will emit a Kubernetes event. So every action that it performs it issues an event and tells you what it has done. For example, here it has told us the Helm chart is not ready because source controller didn't got time to download it. Once it has downloaded, then the Helm install has started, then it has succeeded, and so on. And we have these events for Helm releases, and we also have these events for Flux customizations. If we look at, let's say, infra controllers and we look at events, we see here the events issued by customized controller, where we say, hey, I'm progressing, I'm creating all these objects, I've done reconciling them, and I'm going to check if anyone have made any changes directly on the cluster with kubectl apply in 1 hour from now. And also how long it took before all these objects were ready. It does this health check where it looks at, as I said, at everything that it deploys. We can also see things like the actual definition of a deployment, for example, right? So here is a view of the actual YAML as it is in the cluster, which is very different from the one that's in the Helm chart, right? Here you can see all the things that Kubernetes has added, manage fields, status, and so on. It's more like, instead of having to connect to the cluster and do a kubectl get -o YAML and so on and investigate all sorts of things, you can use the UI for that as well. Okay, so I've shown you how I can deploy Helm charts and how can I configure cluster add-ons and all sorts of things that are part of the cluster infrastructure, something that, I know, an app developer doesn't really care to set up and manage, right? This is more on the responsibility of the platform team and platform admins, right? They are the one that will own this repository, and they will configure the infrastructure bits. Now, how can I onboard applications onto this cluster from other repositories, other sources? I don't want in this repo to have the Kubernetes deployments, the configuration, everything for every single app that I'm deploying. I want those definitions to be owned by the app team. They can have it in their own Git repo, maybe next to the app source code, and so on. Right? So the idea behind Flux version 2 is that even if you bootstrap a single repository, we allow you here to define other sources. So even if this is, let's say, the entry point for your cluster, from here you can refer to external sources. And one way to onboard applications will be, I'm going to create a Git repository object for where the app definitions are. It will probably look similar to this. And I'm going to, configure a deploy key for that app repo, and I'm going to pull the app manifest from there and deploy them on the cluster. That's one option. Now, another option is let's say you teach your app devs to write Helm charts, and they will publish charts to a container registry. And from there, instead of deploying the app directly from their Git repo, the app deployment will look something like this, with a Helm repo, a Helm release, and values. Right? That's one option as well. I want to show you a third option, which is something quite new and unique to Flux currently, is how you can onboard app manifests from container registries. How is this different from connecting directly to a Git repo? There are, even if the things are quite the same, instead of a Git repo, you'll create an OCI repo. OCI does not mean the Oracle Cloud is Open Container Initiative. And in the Flux APIs, that means you connect to a container registry. So the advantage of using a container registry instead of a Git repo to pull app manifests are various. One, you don't have to deal with SSH. You can, let's say, if you are using, if you are running your cluster on a cloud like Azure or AWS or Google Cloud and so on, you can use Kubernetes workload identity. You can tell Flux, hey, use this identity to connect to the container registry, so you don't have to set up any passwords, you don't have to rotate SSH keys and so on. And second, at scale, when you deploy tens of thousands of applications, doing Git operations for all of those, reaching out to all these Git repos, pulling all these changes, dealing with, Git history and everything that involves the Git protocol is way, way heavier than just do what a Docker pull command means. All right. Okay, so let's deploy an app. I have this apps directory, and I have here, I will talk a little bit about namespaces and everything. And I have here a demo app, Podinfo. It's a tiny app written by me in Go for demos. And this is how I refer to where these app manifests are. I'm creating an OCI repository. I'm giving it the URL to the GitHub Container Registry, manifests, Podinfo. I'm telling Flux to verify this artifact using cosign and keyless verification. And I'm telling Flux which tag to deploy. In this case is 640. So this is how I'm defining the source of my application. Where are the Kubernetes manifests? They are here. And with, again, a Flux customization, I'm setting up, okay, use this source and deploy this app in the app's namespace using this service account. And I'm going to explain a little bit what this is all about. But first, let's enable the app deployment. I'm going to rename this. So Flux will see it. If I go here, and I have committed the changes, right? And during Bootstrap, I configure Flux to watch the Bootstrap repo every minute. So in about 1 minute, I should see things happening. I can also do here from the UI, I can do sync with source and so on, but let's wait a little bit for Flux to detect the change. And I want to show you the order of things, how they are executed. Now, if I'm looking here in my apps, I see that the apps depend on infra configs because maybe my apps need some custom resources, some other settings, network policies, all the things that I need to secure my apps. So, okay, it has started. And for the apps, it says status not ready, dependency infra config is not ready. What Flux does is, hey, it has detected a change in the main repo, and now it follows all the steps in the pipeline. It verifies, hey, there is any change in source or in cluster for the controllers. Do I need to do anything with the controllers? No, they are ready. Next one, configs. Are they up to date? Has anyone changed them in the cluster? Do I need to correct the drift? No, and so on. Then it goes to the application side, has deployed the apps, and now podinfo has started. And we see here a nice verified check where it says, hey, this app has actually been verified, and it comes from this revision. If I'm going here at sources, I can see I have a new source called podinfo. It's an OCI repo. It's verified with cosign, and we can also see the exact digest that was pulled from the container registry. Digests are like commit shells, if you want, right? You can, in the Flux world, you can refer it by a tag, but Flux will always resolve a container image tag into a digest, and it will use the digest everywhere. Tags by default are not immutable. So if someone pushes a new image over 640, even if the tag is the same, Flux will discover, oh, the digest has changed. It will let you know there is a new digest, even if the tag hasn't changed. It will apply the changes from there. Of course, it verifies it first, and only if the verification works, and so on. Okay, so how am I publishing these manifests from the podinfo directory? If I go to my repo, let's go to podinfo. I'm going to look in my GitHub workflows. On the release workflow, I do a bunch of stuff here. I'm building the container, I'm setting provenance, SBOMs, everything for the container image. And after the app container has been pushed, I'm running this command, flux push artifact of the manifests from my repo, which are deployments, horizontal pod autoscalers, whatever. So I'm using Flux the CLI to bundle all my app deployments into an OCI artifact and push that artifact to my container registry. So every time I'm doing a new podinfo release, this CI workflow runs and it does a Flux push. That doesn't mean it's not like a kubectl apply, right? It doesn't connect to the cluster. It pushes the artifacts to the registry, and from there, Flux picks it up based on policy configuration that the cluster admin has configured, and only then it gets applied. But even if the actual apply system is managed by the platform team, the cluster admins, and so on, how can they protect themselves from me putting here in my podinfo deployment something that deploys to other namespaces or creates namespaces, maybe creates cluster role bindings and gives me access to the whole cluster. Flux has a mechanism for that, and is part of the Flux multi-tenancy feature. And how can a cluster admin onboard some repo that it doesn't trust and limit what things can be in that repo? We didn't invent role-based access or anything. What we are doing is we rely on Kubernetes RBAC to do this lockdown. And we have this thing in the spec of a customization, which is called service account name. And we tell Flux, hey, use this service account name when you deploy workloads from the source. So what I'm basically doing here, I'm assigning a service account name to a particular source. Then in here, where I define my app namespace, I'm creating a role binding for this service account. And because it's a role binding, it limits the access of the service account to this particular namespace. And I'm giving it here the cluster role admin. Admin is different from cluster admin when you do even if it's a role binding. An admin cannot change things in its own namespace, and it cannot fiddle with the quotas of the namespace and so on. But the admin role allows this source to contain things like deployments, service accounts, RBAC, but that RBAC cannot, bypass the one here. So you can't add if you add the cluster role binding, if I'm adding a cluster role binding to my podinfo manifest, when Flux will reconcile the app, it will error out. You say, hey, I'm not allowed to create this role binding because I'm running as the dev team, and the dev team is limited to these permissions. So this is how Flux allows you to limit the access of what other repositories, what other sources can contain, and what actions can they do on the cluster. So that's one feature of a Flux customization. Another feature is called customization, right? So you should be able to change whatever is in here with customized patches. So we have these patches entering the spec, and for example here I can change the horizontal pod autoscaler. I can do whatever I want with customized patches on this source. So if I change here the min number of replicas, and if I do info 3 replicas, and I'm making this change, okay, this has been synchronized. I can go here in the apps, and instead of waiting 1 minute, I can tell from the UI, can tell Flux, hey, go and sync it now. And let's see what will happen here. So inside the deployment, no, 1 second, in the graph, now I have 2 pods. The horizontal pod autoscaler will be updated, and the horizontal pod autoscaler will reconfigure the deployment. So maybe I synchronized the wrong thing. Let's see. I can also go to source, Flux system, and sync this one, which should pull the whole thing instead of waiting. Okay. Dependency is not ready because it goes through all the layers again, right? It checks everything until it gets to the application. We can also change the behavior and make it very, very fast. And I hope I have enough time to show you that as well. So now if I go to my pod info, I see that replica has progressing. The horizontal pod autoscaler is now waiting for desired replicas. The target is 3 instead of 2. And this one will take a little bit to roll out. And now it's all done. And now if I go to the graph, I should see here that I have 3 pods and so on. Right, so this is like a small example of what I can do without having control over the original source of an app. I can use the Flux constructs, the Flux customization in this case, or the Helm release with these values to change and fine-tune some external app for my own usage. How is it saying? Do you have still time or? Okay, I'm going to show you one more thing. How can we make Flux configure itself? So in here, inside the Flux system, we have customization.yaml, right? So this is like a customized overlay that contains all the Flux controllers and their configuration. Now in here, I can tell Flux to patch itself. And I have a patch here which increases the concurrency of all the Flux controllers. So instead of being able to deploy only 4 things in parallel, I'm telling it to deploy 20 things in parallel. This is part of the vertical scaling configuration. You can also do horizontal scaling for Flux controllers with sharding and so on. And I'm also telling Flux to requeue dependencies way faster than it does by default. So it becomes more snappier. I can commit this and say Flux master. So if I'm looking here, I can filter by deployments. Or no, not like this. No. Here I can, yes.
So while you are doing, Stefan, there's a one question from Rodan on the chat. He said, what's the pattern for multiple cluster managed by Flux and to achieve high availability of Flux?
I will answer in a minute. So inside the Flux customization, it manages Flux itself, right? So you have Helm controller, customized controller, whatever. Now, without going on the cluster and changing these configurations directly, I have went into the Git repo and I told Flux, hey, reconfigure yourself in a different manner. Like, for example, what I did here, I said, be snappier, be more fast to retry dependencies. So we don't have to wait that much until the apps get deployed. So after Flux detects the changes on its own configuration, it should start rolling out its own deployments. Now, in the Flux documentation, I'm showing you what will get into the docs in the next release. By the end of this month, we are doing revamping of the doc structure. For example, we have Bootstrap and all the Bootstrap flavors, GitLab, whatever, configuration. And here under configuration, we have horizontal scaling. So if I'm running Flux at scale, and I have, let's say, a management cluster, I'm installing Flux here, and I want to deploy from the management cluster and control other clusters. So Flux can do that. Flux can take one or more kubeconfigs, connect to remote clusters, and deploy and manage those clusters there. It's integrated with Cluster API. So for example, in the Bootstrap repo, you push your cluster definitions. Flux will reconcile the cluster definitions. We wait for the cluster to be created. Then it can automatically connect to that cluster and deploy their, I don't know, CNIs, ingress controllers, applications, and all of that, right? But if you have hundreds of clusters, thousands and thousands of applications, having a single pod, a single controller instance that manages all of that, let's say Helm controller, and you have like 10,000 Helm releases, it will take a very long time if you change them all at some point, or you make a change for 100 of those. The idea behind sharding is that using a simple patch that you put here, the same stuff I did right now in this one. You'll put here a special patch that is documented in the Flux docs that will spin up new controller instances, and will assign each instance to manage a part of the custom resources, not all of them. And how we do that is basically we shard all the Helm releases based on a label. And the label is called Flux shard, then you give it a name, shard 1, shard 2, shard 3, whatever. So what will happen is that, let's say you have 10 clusters, you can create a shard key for a group of clusters or have a shard key per cluster name. So you can spin up a dedicated controller instance, a dedicated Flux controller for a particular cluster or for a particular namespace or for a particular tenant and so on. How you do sharding, what sharding strategy you choose, it's up to you. We give you the tools. It's just a Kubernetes label on a custom resource and a little bit of configuration on the controller side, and that controller manages that shard. So that's how you can do horizontal scaling. We didn't saw the change, but let's look. Yeah, so here in the repo, we said, hey, I want to bump the concurrency to 20 and the requeue dependency interval to 5 seconds. And Flux has reconfigured itself. If we look here in the container arguments, we have these settings applied. So customized controller basically changed its own definition. It has restarted, and it has restarted with the new configuration. And in the same manner, you can do Flux upgrades. We also offer a GitHub action that can run in your CI. It detects, oh, there is a new Flux version. And what it will do, it will update this file. In this file, it will commit the new version. It opens a pull request. Once you merge it, Flux will upgrade itself. Going back to the multi-cluster question. So you can run Flux in 2 ways. As I said, you can run Flux on a management cluster, and from there, you have these kubeconfig secrets where you tell Flux to connect to all the other clusters. That's one way of doing it. I'm not a fan of this operation model, because then the management cluster becomes a single point of failure for everything. All your deployments, your whole continuous delivery pipeline will go down. My preferred way of doing it is by running Bootstrap on each cluster and use one repo and many clusters here. So you run a Flux instance per cluster. They run independently, but you can control it from a single repo, right? That's what I would do. Now, the problem is, if you have like hundreds of clusters, are you going to run Flux, Bootstrap, GitHub, this cluster, and so on by hand? You probably are not going to like that. So how can you, programmatically do Bootstrap? We offer a Flux Terraform provider that shares the same code with the CLI, so the exact same procedure of Bootstrap and everything that I've shown you today. You can do the same stuff from Terraform. So you can have a Terraform script that creates the cluster, connects to GitHub or GitLab or whatever instance, sets up the deploy key there, and then runs Flux Bootstrap, giving inside Terraform, giving that deploy key to Flux. And you can fully automate this across hundreds of clusters using Terraform. And I think Pulumi also has a similar thing for Flux. The idea is that you should be able to run Flux Bootstrap right after the cluster creation in an automated fashion. And we have lots of users which are very happy with our Flux Terraform provider. As a final thought, I hope you like the demo and what I shown you today. I would like to point you, if you are getting started with Flux, I would like to point you to the official example repo that we have under the Flux CD organization. What I've shown you today is a very slim version of what this repo contains. It's structured in the same way. It shows you here how you can do staging and production, how you bootstrap two clusters. For example, in the infrastructure part here, in the controllers, you have a cert manager, ingress and Nginx. On staging cluster, you provision certificates with Let's Encrypt from staging. On production cluster, you you provision certificates with the production Let's Encrypt and so on. And it shows you how you can, for example, create customized overlays for each environment. For example, here in apps is way more complicated than what I showed you. It's a base, and we have these production overlays. In the production overlays, we have different values where we change the host name, the path, and the version, and so on. So yeah, if you want to get started with Flux, I recommend looking at this repo. It has a lot of explanation also around the repo structure, how you can do all things. The only thing that this example does not show you is the new OCI repository pattern, where you push the manifest with Flux CLI, then you pull it from Flux. Here, it's only about Helm and how you can use customized overlays for Helm releases and change things. So yeah, that was it. I hope you like it. I'm going to stop sharing now.
Thanks, Stefan, for the wonderful demos. And I won't interrupt you, but we have to interrupt you and we have to close it down because they're short down. But I learned a lot. I think really good, wonderful comments in the chat about the workshop today. You did a great job of presenting and telling people what the power of Flux could be and what are the various other ways you find it. So few questions for the people who has they around Flux UI. Well, one of the questions from Ingen, they say like, what is the future of Flux UI, or what are the plans for Flux UI in particular?
Yeah, so Flux UI is not part of the CNCF organization. Flux UI, what I've shown you today, is called with GitOps. It's open source UI made by Weaveworks. What we have decided for the Flux project is more like Lego pieces. It has all these controllers, it has a CLI to pick and choose and deploy them, and we encourage vendors to offer their own Flux distribution, and we have all these APIs, so anyone can build UIs on top of it. Azure has its own UI for Flux. GitLab is working on a UI. Weaveworks is offering this open source UI and an enterprise edition of it, and so on. For the Weaveworks side, the open source edition, the goal for the UI is to cover everything Flux. All the custom resources, you should be able to debug anything goes wrong and take a peek into how Flux is doing things. Also, it's integrated with the Terraform controller, which is an extension of Flux. So it's not only about the UI showing you all the things that Flux deploys on the cluster itself. It's also about it's a UI for showing you how Flux provisions using Terraform and Terraform controller infrastructure outside the cluster, right? So it tries to give you this holistic view of everything that's part of your production system.
Yes, and you mentioned one of the cool thing I really like about, and I think if people are unfamiliar with it, so you can give some pointers on that. We talk about during the conversation Flux controller for Terraform. So number one question people have in their mind, let's say if we can spun Flux controller for Terraform, I think few people can ask question like this. If those Flux controller for Terraform can add, or we can actually see the visibility in the UI, for the Flux controller for the Terraform? I think that's the number one question for the people. And the number two question is, what is actually the current status of the Flux controller for Terraform?
So the Flux controller for Terraform is at version 1 alpha 2, the custom resource definition, it's API. It has been used by lots of organizations in the last couple of months. And I think Terraform controller will go to beta by the end of this year in terms of API and stability. There are also lots of improvements on that side around being able, for example, to run, to interact with pull requests that modify the Terraform script. So you open a pull request, then Terraform controller will create a plan, and it will show you that plan, how your infrastructure will change if you merge that pull request and stuff like that. So I think in the next Terraform controller release, there is a thing called the pull request planner, where the Terraform controller interacts with GitHub pull requests and tries to do that. I think also on the CI side, you can run something like Atlantis. I think it's called the project. So this is something similar, but in the GitOps way for Flux. Another thing that the UI is trying to integrate with, and I think it will be fully integrated next, is a policy agent for Flux. So it's a policy agent based on OPA, which is dedicated for Flux, or where you can enforce all sorts of policies for building continuous delivery pipeline with Flux, like things like only these types of sources are approved on this cluster, or things that are in these sources must comply to these rules, and so on. So this also helps with, going beyond Flux multi-tenancy, where it's all about at the apply time you get the error, right? I'm trying to create, I don't know, a cluster role binding in this service account and it fails. The policy agent tries to do this at admission, and also as a CLI that you can run in your CI pipeline before you merge anything to Flux, and to tell you, hey, these things that you added here, even if you merge it, it will never work, right? So catching and enforcing policy early on in the pipeline, especially at pull request time, I think is the best approach for Flux. Of course, Flux will error out and let you know through notification control, see on Slack, on PagerDuty, whatever, hey, this thing has failed, but it shouldn't. Most things can be stopped before it goes on the cluster. And I think WeWorks tries to cover this better in the pipeline.
Yes, absolutely. I think everybody was listening to us. And I think one more question. Does crossplane works with Flux?
Yes, sure. Anything that has a custom resource and can be placed in a YAML file works with Flux. I know, crossplane, Pulumi, even Terraform, which is not YAML, right? So there were, I think, talks at KubeCon around Flux and crossplane. There were like many demos. It
Yes,
works fine.
absolutely. Absolutely. There's a learning resources section in the Flux UI, in the Flux documentation, and all the talks, GitOps, Con, or all the GitOps related content for the Flux is dedicated in here, fluxcd.io/resources. And I believe some of the talks around the same question that Warren you asked. So please make sure you ask some of the content in there. So now I can stop here and we end the conversation. I believe people will finally see, and there's a whole lot of debate around UI, and UI, and they finally see it, and it's a very great one actually. It's a very much needed one. It's a dependencies graph. You can see it, and all the things you're missing in that century. Like, why not Flux as a UI? It has it, and it works tremendously well, and you see a demo how perfectly it's work. So do try it out. Here's the repository link I can share with you. I think everyone who joined today, I'm really excited. So try out, let people know like how you actually going to be reconciling GitHub resourcing using a Flux UI. Please do that. And there's a workshop exercise file that Stefan added for all of your reference if you want to try out in your home as an sandbox environment. Please use it, this repo, as a starting point to learning Flux. Flux 2.80 GA came out, and we are really excited about because it's a 5-6 year of effort, and now you're ready to run this wonderful project in production setup. There are quite notably changes in the APIs, and if you read this blog, I think you're really happy to know it. Flux becoming a thing in the Azure, Flux becoming a thing in GitOps, and you see more and more cloud will be adopting Flux as a default GitOps controller in the cloud because it's telling you it's highly customizable. You can tune it based on the organization specific need for the cloud native deployment. So that's the beauty of this project. And also, as Stefan said, is a built-in supply chain security model, and now policy is in place. You don't need to worry about when you actually deployed in the cluster, and then the policy engine you install, and then they can configure and let you know why things break on the cluster. So the aim of the game right now is to, before breaking the cluster, we actually tell you why it's broken if you deploy the certain things into the cluster. So that's another wonderful thing. So I will be talking about, but that's a one step part one of the Flux workshop. And moving on, we keep on busy, keep Stefan busy with these types of workshops for sure. It's a great audience we see today. Really like people are commenting and watching and asking question. Is one of the great
Awesome.
workshop, innovated one. And thank you very much, Stefan. I really enjoyed it. But I do well let people know that we're hosting another workshop on another Thursday, leveraging Kubernetes to enable cloud native development experience from a guy from Octato company. So please join as well. And with that, I will like to say goodbye everyone for joining
Right.
and
Thank
asking
you.
the question, and stay here till the end. Stay safe, stay healthy. Have a wonderful day, everyone. Stefan, and have a wonderful day
Bye-bye.
who join us in the chat.